And today we're going to start off with surface area. Well, the definition of surface area is a two-dimensional measurement of the surface of a solid figure. In other words, so if you remember from volume at all, volume is how much it takes to fill an item up, like fill something up with water. Surface area is taking those two-dimensional areas. It's like all of the things that encompass this figure and just adding them together. So the way I kind of look at it is I want to figure out the area of everything I could paint on this object. So if I had to buy paint and I had to know how much paint I need just to cover this, and this, that's surface area. The other thing I think about is just like if I cut out cardboard. How much cardboard do I need to actually construct this object? I'm not worried about filling it. I'm just making a hollow object, right? So that's our surface. It's our area of all of our surfaces. That's why we call it surface area. And the easiest way to come up with surface area is to break down all the different surfaces that encompass that object. So we're starting off with finding the surface area of something called a regular pentagonal prism. A regular pentagonal prism. So a prism, we'll talk more about it tomorrow, it's just a shape with a flat base and a flat top and vertical walls encompassing everything. That is a prism. And since it's pentagonal, it means that our base and our top are pentagons. I almost said pentagrams, but pentagons. All right, so if I'm asked to come up with the surface area, we can either draw the net, which I drew up there, or we can just picture all of the shapes that make it up. So this object right here is called the net. It's called the net diagram. It is all of the two-dimensional shapes that make up that three-dimensional pentagonal prism. So to come up with our surface area, I need to know what the area is of this pentagon, this rectangle, this rectangle, this rectangle, this rectangle, rectangle. Add it together, and I have my entire surface area of this object. So it's just finding little bits of area and adding everything together. The good thing is this pentagon is the exact same thing as this pentagon. This rectangle is the same shape as this rectangle, as this rectangle, as this rectangle, and this rectangle. So I really only have to find two areas and just add everything together. So the first thing we're going to do is we're going to find our pentagon. We'll find the area of our pentagon. So area of our pentagon. Well, our area of our pentagon is going to be half our apothem times our perimeter. Half our apothem times our perimeter. So the area of this particular pentagon is half. It gives us our apothem right here. Remember, that's the line that goes from the center to any side of our polygon, and that's 11. So it's half times 11 times our perimeter. How do I come up with the perimeter for this one? Noah?
16 times 5.
It's going to be 16 times 5, because one of our sides is 5. So 16 all the way across. I guess I could write that on here. 16, 16, 16, 16, 16. So 16 times 5 is 50 plus 30, so that's going to be 80. And so we're just going to have half of 11 times 80. Well, that's 40 times 11. So that's going to be 440. So each of our pentagons is now 440. What was it, centimeters squared? I'll just leave it as 440 right now because I'm not giving it a total answer. So each of those are 440. Okay, now I just need to know that each of these rectangles is the exact same thing, and a rectangle is base times height. So to get the area of my rectangle, the area of my rectangle is just base times height. Well, that's just going to be 16 times that 23. Because each of these sections is 16, and our height is 23. So that's 16 times 23, and that's going to come out to 368. So that means each of our rectangles is 368 centimeters squared. So I'll put that in for you. 368, 368, 368, 368, 368. Whew, that's a lot of 368s. So to come up with my surface area, so my surface area is going to equal all of those areas put together. So we have two pentagons, so that's going to be 2 times that 440. Plus I have 1, 2, 3, 4, 5 of the rectangles, so it's 5 times 368. And so our total surface area for this guy is going to be 2,720 centimeters, and it's still squared. It's still centimeters squared. So 2,720 centimeters squared. So once again, to find our surface area, we just break everything down into all of our two-dimensional objects that make it up and come up with the areas for each of those objects. All right, we're going to move on to a cylinder. A cylinder. Well, I know right now a cylinder has a top circle and a bottom circle I have to paint, right? So we have a top circle and a bottom circle. And if you picture, let's go ahead and use a sheet of paper. So this makes a cylinder, right? But as soon as I open it up, it just makes a rectangle. So a cylinder is made of 2 circles and a rectangle. And most of the time when we draw this, I don't even care how you draw it, but a lot of times when we draw the net of this, we draw a circle up here. We draw a rectangle. And then we draw a circle down here. But you just need to know that we have 2 circles and a rectangle that make up a cylinder. That means I just need to find 3 things. I need to find 2 circles and a rectangle, add them together, and I have my entire surface area. Well, a circle isn't going to be bad. Remember, the area of a circle, our area of our circle is just going to be pi r squared. Well, our r in this one is just going to be 6, so we have pi 6 squared, which equals 36 pi. So each of our circles is 36 pi. This guy is 36 pi. Now we just have to figure out a rectangle. Well, the height of a rectangle isn't hard because it says it's 15. We already have 15. They didn't give me this number, though. They didn't give me that number. Do you have an idea of how we could get that number? Yeah.
You find the circumference of the circle.
It's just the circumference of the circle, right? Because this sheet is going to wrap around this circle. It's going to wrap around it. So whatever length this is has to, and you can picture this unraveling to make this whole length. It's just going to be our circumference of our circle. And our circumference is just 2 pi r, so it's 2 pi times 6, which equals 12 pi. So the area of this inside thing is going to be 15 times 12 pi. All right, then all we're going to do is we're going to take 36 pi plus 36 pi plus 15 times 12 pi. And when we add all of those parts up, we're going to end up with 252 pi centimeters squared. So we add our 2 circles, And we add that 15 times 12 pi to those two circles. It comes up to 252 pi centimeters squared. Questions on any one of those parts? I see a couple people still writing, so I'll just hold on for a second. I guess while people are writing, I can write that down. So this answer here is just that 72 pi plus 15 times 12 pi. Okay. The next shape we have is a cone. Part of a cone is easy to get. The other part is not so easy. So a cone has a circle on the bottom. So we have a circle. That's easy to calculate because we know the radius is 9. So our area is going to be pi times 9 squared, which just equals 81 pi. So that circle right there is 81 pi. The harder part is if I open this up, it's going to be this giant fan sector looking guy.
Because it's a sector.
It is a sector. And we could spend, so the problem with solving for this sector is this angle is dictated by how big our circle is, or how small our circle is, or how long it is going to dictate this angle. So just for right now, I want to cut this off because that did not look, my sector looks terrible. I'm going to tell you right now, the area of this area, and this is an important formula to know, equals pi times r times L. Where L is this 24. L is that length. L is the length from the tip of my sector to the base of my sector. So pi RL is going to be the area of that guy. And you just have to know that. All right, that's one of the things you just have to know. Alex, do you want to pick up your head, please? Thank you. So pi RL, you need to know it. So the area of this one is going to be pi times our radius, which is 9, times our length, which is 24. I don't know if I have that on my sheet. Oh, I do. So that's going to equal 216 pi. All right, so we just have to do 216 pi plus 81 pi. So our total area is 216 pi plus 81 pi, which is going to equal 297 pi centimeters squared. Kind of ran out of room there, but we got it in. All right, so you should have this boxed in, some kind of star or something to tell you have to memorize this. This just has to be memorized. All right, if you see a cone, you have to remember P, R, L. If you ever saw the show TRL, kind of like that, just with pi. All right, the last one we're going to do in class is a regular hexagonal pyramid. So this one's going to take a little bit of doing. Not for the triangle's sake. So if I draw this, we just have a hexagon, and we have 6 triangles. So that means I need the area of 6 triangles. Let's do that first. So our triangles. We'll focus on our triangles first. So the area of a triangle is going to be half our base. Well, our base for this one is 26. Times our height, which is 43. And if we plug that in our calculators, we are going to get out some awesome number, 559. So that means every one of our triangles is 559. So that's 559. That guy's 559. That guy's 559. This guy's 559. This guy's 559. And finally, the last one is 559. So the only thing I have to calculate the area of is that hexagon. The problem with that is did I give you the apothem?
No.
You have to have an apothem to get that area. We can get the perimeter pretty easily because it would just be 26 times 6. But we need to get that apothem first. So what I'm going to do is I'm going to go ahead and I'm going to draw that hexagon off to the side. Because that means we have to do a little bit of work. Alright, if at any time I don't have an apothem, I'm going to draw a triangle. I'm going to draw a triangle from the center to 2 of my vertexes. Alright, so now we have a triangle. I have a triangle that's base is 26. And I can actually calculate the degree measure of that triangle. And can someone tell me how I'm going to get this degree measure right here? Mary.
You can split it in half to find the,
I'm just looking for this degree measure right here. Just the degree.
26, because it's a center.
It won't be 20, because that's not 26 degrees, that's actually a length 26. Other Mary.
When you divide 6, you'll divide that for 360 divided.
There you go, 360 divided by 6, right? Because I can make 6 of these triangles. We did that once. So it's going to be 360 divided by 6 is going to give me that angle. So 360 divided by 6, which is going to come out to 60 degrees. All right, then I'm going to cut it in half. So I'm going to create this triangle here. I'm going to create this little triangle that will give me my apothem. Well, if I cut 60 in half, that must mean that this is 30 degrees, which makes this guy 60 degrees, which makes this 90, and it also gives us a length of 13. Now, if I have a 60, 30, 90 degree triangle, my one across from 30 degrees is S. The one across from the 90 degrees is going to be 2S. And the one across, I'm going to move my arrow just a little bit. The one across from the 60 is going to be S square root of 3. Well, S square root of 3, or S is already 13, so it's going to be 13 square root of 3. And this 13 square root of 3 is also my where am I? Okay, so we did that. Let's just quickly go over what we did. So if I have a regular pentagon, we go ahead and draw our shapes. For a cylinder, we draw 2 circles and a rectangle, get that measure. For the surface area of a cone, we have to remember that pi RL is the cone portion. We should know how to figure out the circle. And for any other shape, we just have to find the base and the different shapes that make it up. Alright, these were the shapes that we went over really quick. I want to look at number 9 and number 10, because you have to know something for them to make sense. Alright, so I was looking at number 9. So basically what this is a drawing of is, pretend like you have a solid piece of wood, right? That's in a cylinder shape. And you just take a giant drill and you drill right down the middle. And I pull that drill out. Now I have to paint all surfaces of it. Al, can you pick up your head, please? I have to paint all surfaces of it. So I have to paint the outside. I have to paint the top. I also have to paint this inside. So this hole isn't empty. There is surface area inside of here. So I kind of broke this one down. I broke it down over there. I'm going to break it down up here. So if you look at a normal cone or a normal cylinder has 2 circles, right? A top circle and a bottom circle. Well, in this one, I'm going to have a top circle that's missing a chunk and a bottom circle that's also missing a chunk. Do we see that from the top and the bottom? Okay, then our normal cylinder, if we look at the outside, I have to paint all of this outside. So this whole outside area is an outside cylinder rectangle. So we have one big rectangle. So we have one big rectangle that wraps around the outside. The thing is, I also have something that wraps around on the inside, which is going to be the same size or same height. It's just going to be a little shorter because it wraps around the inside. So if you picture, if I have two pieces of paper, if I have two pieces of paper, so in short, this is that cylinder, right? I have one circle in the center, and I have one circle on the outside. Alright, this paper that's on the outside is this rectangle, and this paper that was on the inside is going to be this rectangle, but they won't be the exact same size. Alright, does that kind of make sense? I just want to make sure that you don't just find this area and subtract, because this actually has some extra area added into it, so I have to paint all of this inside. Just like on the square, I have to paint all of this inside, so I have to calculate all of that surface area that's on the inside of the circle. Once again, all that's inside of there is a square with a rectangle turned up. We just have to open it up and figure out what size that is. Okay, and that goes back to our cylinder problem. Okay, let's go ahead and get started. I do have the answer key. I want to put it out in a second. Actually, I'll put it out right now. Just because the barn problem has a bunch of words, it's doable, so don't quit because it looks hard. Alright, it's very doable. It's about finding triangles, trapezoids. Just remember the area of a trapezoid is half the height times base 1 plus base 2. And then you just have to do rectangles. So it's rectangles, trapezoids, and triangles, and that's it. I'm going to go ahead and post that solution key online right now.